The KDC creates a secret key for each member. There is a concept known as ticket. Sender will request a ticket for Bob. Version 5 can accept any symmetric key algorithm. Hello students, welcome to the next session of Network Security. Let's know about the key management in the digital signature, or generally how does the key is managed in asymmetric key cryptography, okay, or any general cryptography. In this session we are going to explain about various key management techniques, okay. So we have the symmetric key distribution. How does the key in symmetric key cryptography is going to happen, okay. So symmetric key cryptography is more efficient than the asymmetric key cryptography for enciphering large messages, because asymmetric cryptography uses two keys, private and the public key. So it takes much time to generate two keys, to transmit them, to encipher them and decipher them takes much more time. For large messages, it will take much more longer time, isn't it? For that purpose, or for that reason, the symmetric key cryptography or symmetric key that is generated in the symmetric key cryptography is the efficient method than the asymmetric key cryptography. The symmetric key cryptography, however, needs a shared secret key. As we know, symmetric key cryptography uses single key which is shared between a sender and a receiver, okay, between two parties. The distribution of keys, how do you make the keys available to the receiver without attackers getting to your key is the main problem in the symmetric key cryptography. Only one key is sent from the sender to the receiver. The attacker may easily gain the key. That means even the plain text can be obtained by the attacker. So the main problem here is the management of the key in case of symmetric key cryptography. Okay. For this, we have a special method called as key distribution center. So we have or the cryptographic methods or the field of cryptography has proposed a concept of key distribution center, which is a special program which is meant for distributing the key between different senders and different receivers. Why the key distribution is problem is the sender is one, it is a one-to-many relationship. If you have 10 receivers, 10 keys has to be generated, new keys has to be generated. The sender can do that if they have only limited number of receivers. If their number of receivers exceeds, suppose if there is 1 lakh receivers for a single message, the sender, is it possible to create 1 lakh new keys? It is not possible, isn't it? It is very much difficult to create that many kind of keys. So that might be even unique keys, isn't it? So it is a difficult task to create a key in the symmetric key cryptography. For this problem, the solution is the key distribution center. Okay. So key distribution center, or is known as KDC, uses the center. It is a center which is connected with all the senders and the receivers. Okay. So each KDC is connected to each of the sender and the receiver, who acts as an intermediary between the sender and receiver. How does it works is the sender sends a message to the KDC requesting, suppose if Alice wants to send a message to Bob, what he has to do or she has to do is, first Alice will send the request to the KDC stating that she needs a session secret key. So there will be a session created for each of the message distribution in the key center. Okay, in the KDC, it creates a message session for each of the message to be distributed. There will be a secret key or session key which is distributed or which is established between a sender and the KDC and receiver and the KDC. So each member of the KDC, whether may be sender or receiver, will have a secret key. So that secret key is referred to as, if it is Alice is the sender, the secret key is K Alice. If it is receiver is Bob, the secret key with Bob will be K of Bob. Okay, like this we'll have secret keys with every sender and receiver. Whenever a sender wants to send a message to the receiver, they can't do it directly. They have to establish a connection with the KDC, between KDC and the sender and the receiver. Then they have to send the message. What is the procedure is, if the Alice wants to send a message, she will send a request to the KDC requesting that I want to send a message to the Bob. Okay. Now, what does the KDC will do is, KDC forwards this request to the Bob with the secret key. Secret key is already established. The KDC sends this request message to the Bob stating that Alice wants to send a message to you. If the Bob agrees to accept the message, then KDC creates a session. So suppose M1 is the message. For M1, a session is created between the Alice and the Bob. Suppose Anne wants to send a message to Betsy or George, it will have another message M2 and a session key S2. So using the session key, the messages can be exchanged. So the KDC acts as an intermediary between the sender and the receiver. The KDC is the one who authenticates both the sender and the receiver. Okay. Now, the general concept is like this. The next thing is to know the flat multiple KDCs. Suppose if it is in one single area, one KDC is enough. If the sender and the receiver is far away, you can't manage this length or this distance with only one KDC. Instead of that one KDC, we use set of KDCs in different areas or different locations and which are connected with a sender and the receiver. So we have the sender and the receiver. With this, we have multiple KDCs. So flat multiple KDCs, they are all in a single layer. Whenever Alice wants to send a message to Bob, the Alice sends request to the connected KDC for which secret key is shared. Okay. So this KDC sends the request to another KDC which is inline. They are synchronous. They are linear in operation. So like this, it reaches the KDC which has secret key of Bob. Okay. So when there is a request, he sends the request to the receiver. When receiver approves, the KDC which has secret key with receiver sends back the request accepted message back to the Alice with the connected KDC. That is, if it is KDC1, KDC1 will be accepted or will be having secret key with Alice. So he sends, or the KDC1 sends the accepted message to the sender. Now they are all synchronized. Now the Alice can send the message. This involves multiple KDCs. The previous one was the basic concept with only single KDC. How does it works? Okay. Along with that, this is in a similar area. If it is a global one, if it is having, we are in Karnataka, we want to, the sender is in Karnataka and the sender wants to send a message to someone sitting in California. Now, we have to cross the barriers of state, national and international barriers will be there, isn't it? Or international, national and state standards will be there, or local area standards will be there. How do you manage or how do you send a message to a receiver who is somewhere else over the national geography or national territory? So what we can do? For this, we have the hierarchical multiple KDCs. In this, we will have international KDCs, national KDCs and the local KDCs. Okay, international KDC, national and local KDC. What does the Alice has to do if she wants to send a message to Bob? How do she achieves this? First, Alice sends the request to the local KDC. That request will be forwarded to national KDC. Now, national KDC forwards that request to the international KDC. Now, what does the international KDC will do? It will find out the receiver's location, where it is. Once the location is found out, it forwards the request to the national KDC at the receiver's location. From national KDC, it reaches the local KDC and the local KDC will send that request to the receiver. Once the receiver accepts the request by the sender, again the message is sent in the same manner with the hierarchical multiple KDCs. This will make work distribution easier among different KDCs, and tracking of the packets, tracking of the data will also be easier in case of KDCs. Then we have the session keys. What does the session key will do? The KDC creates a secret key for each member which are connected to the KDC. All have a secret key which is unique for that sender or the receiver. This secret key can be used only between the member and the KDC, not the other members, only one member. Say if it is Alice, we'll have a key for secret key between Alice and the KDC. So this key will be used only between the Alice and the KDC, not with the Bob. Bob cannot use this secret key to communicate with the KDC because Bob's secret key is different. So if he wants to communicate with the KDC, he has to use his own secret key. Okay, it is not between two members. So you cannot use the key for Alice, secret key between Alice and Bob. Or she cannot use secret key by Bob to communicate. They have to go through the KDC only. Okay, so a session symmetric key between two parties is used only once. Okay, along with secret key, there will be a session key. Session is for every transaction is considered as a session. For each session, there will be a session key generated. So a session symmetric key, session key will be approved by both the sender and the receiver and is generated by the KDC. A session symmetric key between two parties is used only once. When there is another transaction, another session, a new session key is introduced in the symmetric key cryptography. Okay. Now we shall know about a simple protocol using a KDC. How do you manage the message distribution between the sender and the receiver and the KDC? Okay, so we have first approach using the KDC. We use two keys, KA and KB, and a session key between Alice and Bob, and we have the key distribution center. So what is the first step is, Alice sends secret key, identity key to the Bob along with his identity. Alice secret key along with Bob's secret key will be sent to the KDC. So Alice sends the identity of herself and the receiver. I am Alice and I want to send a message to Bob along with the plain text for request message. Request message in a form of plain text will be sent along with the identities of Alice and Bob, that is the sender and the receiver, will be sent to KDC. Here it will be a public message. Anyone can get access to that message. There will be no privacy or secrecy in that message. Alice wants to raise a request for the session, new session or new transaction by sending a request message along with the identities of Alice and Bob. Now, KDC sends the secret key of the Alice and the Bob to the Alice along with the session key. So, the KDC sends session key for both the Alice and the Bob. Now, Alice receives this message. She reads the secret session key and the secret key. But she will not be able to read the secret key of the Bob because it is meant only for the Bob, not for the Alice. So, she can read only this key but not this key using the session key. So, session key, 2 copies of the session key is sent as a pair with the secret key to the Alice. This is the next step that can be followed. In the third step, along with the request message, the Alice sends the secret key of Bob along with her identity, Alice and Bob. When it is transmitted over network, Bob has to know he is the one who has to receive that message. So, identity of both Alice and Bob is sent here along with the session key. Now, it reaches the Bob. That is the last step. Third step is sends the secret key along with the session key along with identity. This will be sent to the receiver. This is a plain method of sending a request to the receiver, which is an open message which can be viewed by anybody. Okay. So, now we have an improvised version of this, that is the NEEDHAM-SCHROEDER. We have the improvised version of this normal or simple protocol with KDC, that is NEEDHAM-SCHROEDER protocol. It is an improvised one. We use the encrypted Alice KDC secret key, encrypted Bob KDC secret key, encrypted with Alice Bob session key, then session key between Alice and Bob, and we have the RA, that is a random value is selected, which is known as the Alice nonce. Nonce is nothing but a value to be shared between the sender and the receiver, only between sender and receiver. Bob also has a nonce, which is a random number represented as R of B, Bob, and R of A is of Alice. Nonce of Alice and nonce of Bob. Now, Alice, first step is Alice sends her identity along with her nonce value to the KDC and a plain text message. It will be sent to the KDC in the first step. What happens in the next step is there is a concept known as ticket. So, this ticket is created by the KDC in normal protocol implementation as well as in NEEDHAM-SCHROEDER protocol. So, we use the NEEDHAM-SCHROEDER protocol, which is the basis of the simple protocol that we use. The KDC creates a ticket along with the secret keys of both the Alice and the Bob and the session keys. They are made a packet along with the nonce of RA. Okay. So, RA is sent. So, this is the entire ticket by the KDC. So this ticket contains the details, like we have tickets, normal ticket which is given in the bus, contains all the details, which is the bus number, timings, from where to where you are going, what is the fare, all these things will be mentioned, isn't it? In the same way, the ticket generated in KDC will have all these parameters: secret keys of Alice and Bob, the knowns of the Alice and the identity of the Bob, because knowns of Bob will be with himself. Okay. Since Alice has sent the knowns for the KDC, it will be given as a ticket again back to Alice along with the session key. Okay. Once it reaches the sender, what she will do is, she will forward the secret key along with her identity and the session key. It is a ticket for Bob, where the Alice keeps the RA. She will not send that knowns to the receiver. Only the identity, the sender's identity along with secret key of Bob will be sent along with the session key. So this will be sent to the Bob. Bob gets to know that there is a request for the message. Now what the Bob will do is, he will send the knowns value along with the secret key which is agreed, or which is a symmetric key between the Alice and the Bob. It is a synchronized key which is generated by the Bob. Bob sends the generated secret key K of AB along with the knowns value RB back to the Alice. Alice can now send the secret key K of AB. This is a challenge made by the Bob, which sends, or he sends the synchronous key along with the session key to the Alice. Alice responds to this message or challenge, where the knowns value will be RB of -1 instead of RB. One value will be deducted and the request will be replied. The challenge will be accepted by the Alice to respond to the Bob. Okay. This is a Needham-Schroeder protocol that we can use in a KDC distribution. The next version or next method of KDC is OTWAY REES protocol. We can use this protocol to again send a message through the KDC. In this, you have so many methods. It is a improvised version of the Needham-Schroeder protocol, where we use the encrypted key. All the keys and the message will be encrypted in both the protocols. Okay, encrypted secret key with Alice and KDC, encrypted secret key with Bob and KDC, encrypted session key with the Alice and the Bob. Then we have session key between Alice and Bob. This is encrypted, but session key is not encrypted. It is in normal plain text, but the secret key or encrypted session key will be shared between the Alice and the Bob. Then we have another knowns from Alice to KDC, that is RA, and knowns from Bob to KDC RB, and we have third knowns, that is the R. So it is the identities of both the Alice and the Bob. Then what is the first step in this OTWAY REES protocol is, first step is Alice sends the identity along with a common knowns between Alice and Bob with a secret key, encrypted secret key between Alice and KDC to Bob. First connection establishment is between the sender and the receiver, along with the identity, and the knowns value will be sent to the Bob. In the next step, Bob sends the secret key of the Alice, secret key of the Bob along with their identity and the nouns values. So it will be a ticket. So it will be a message sent to the KDC. KDC will create a ticket with the session key. All these values will be included and adds a session key. Till step 2, there was no session key. All will be encrypted messages and the keys sent. Here, the KDC, in this ticket, KDC adds the session key to the ticket. Okay. In the next step, 4th step, the Bob, this is sent to the Bob, the receiver. Bob, what he will do is, he will send the nouns value and the session key along with secret key of A is sent to the Alice. So Alice responds to this message by the receiver and passes a message along with the encrypted session key to the Bob. So Bob receives the message using the KDC and the sender. Okay, this is a OTWAY REES protocol which uses the sender, receiver, KDC and a ticket and 3 sets of nouns, a session key and the encrypted secret keys. Okay, this is about the normal key management. In this, we have a special key method or the KDC known as KERBEROS. So KERBEROS is an authentication protocol and at the same time a KDC which has become more popular. So several systems including Windows 2000 use the KERBEROS. Originally designed at MIT, it has gone through several versions. We have several versions of KERBEROS in this. Here we have the servers in the KERBEROS which has 2 servers, the authentication server and the ticket granting server. The Alice uses the message or the KERBEROS KDC server which uses 3 servers, that is a authentication server, a ticket granting server, another one is data server. So it sends request ticket for the ticket granting service. The ticket granting service or the KDC sends Alice TGS session key and ticket for the TGS. So it will be forwarded to Alice or the sender. Sender will request a ticket for Bob. Now what does the KDC will do is, Alice Bob's session key and ticket for Bob will be generated so that it allows the Alice to send a message. The request access will be given with the server. Okay, so server is the receiver here. So server grants access to the Alice to send a message. Okay, so here we have 3 servers. Authentication server, it is in the KDC which uses for the authentication of the sender and the receiver. Then we have a ticket granting server. The ticket granting server issues a ticket for the real server or the real receiver. Whereas real receiver or server or Bob provides a service to the user. In case of this, the Bob itself is a data server or a receiver. Both are the same. It involves the real server provides services for the user. Okay. So this is an example which is given in the KERBEROS. How does it is going to perform in the KERBEROS? How they are going to generate the message. Okay. So you can use different servers for this. If Alice needs to receive services from different servers, she need repeat only the last 4 steps in the operation. Last 4 steps, this and this. Because establishment or identity is already stored in the KDC, Alice sends the request. Alice gets the ticket for TGS. So in the 3rd step, Alice sends a ticket for TGS forwarded with the Bob's ticket, the key for authentication, all will be sent to the KDC. KDC sends back the separate tickets for Alice as well as the Bob. Alice will send this ticket for Bob, and the Bob accepts and sends the message along with the secret key T of A minus B, encrypted session key. Along with that message will be responded by the server. Okay. Last 4 steps can be repeated for any kind of server. Okay. When you look at the Kerberos 5th version, the major difference between the version 4 that we have discussed now and the 5 are version 5 has a longer ticket lifetime. The version 5 allows tickets to be renewed. Version 5 can accept any symmetric key algorithm. Along with that, version 5 uses a different protocol for describing the data types. Last thing is, version 5 of Kerberos has more overhead than version 4 because it has a longer ticket than the version 4. We use a term known as realms. What is the use of realms is, the Kerberos allows the global distribution of the authentication servers and the ticket granting servers. With each system, all these AS and TGS, we call it as a realm. A user may get a ticket for a local server or a remote server using these realms. Okay, all the 2 systems combined will be called as a realm. Okay. Next thing is to know about the symmetric key agreement. How does this agreement is done with the symmetric key cryptography? Here, Alice and the Bob can create a session key between themselves without using a KDC. So it takes longer time to involve a KDC. So Alice and Bob can create a session, normal session key, encrypted session key between themselves without using KDC. This method of session key creation is referred to as the symmetric key agreement. In this, we have one method, that is the Diffie-Hellman key agreement. So we have the symmetric or shared key in the Diffie-Hellman method is k equals g to the power of xy. X is a value generated by the sender and y is a value generated by the receiver, and is done a modular operation over p. So we have this value. Alice creates a nonce R1 with the value g to the power of x mod p. X is a value generated by the sender. The values of p and g are public. So they are the prime values that are generated. We use the step creates a nonce and is sent to the Bob. That nonce is sent to the Bob. Bob creates another nonce R2 equals g to the power of y mod p. Y is the value generated by the Bob and is sent to the Alice R2, that is nonce R2. Now key is calculated using the expression R2 to the power of x mod p, and the Bob calculates the key with R1 to the power of y. R1 using the Alice nonce and key using Bob's nonce will be calculated key, and they share the secret key with the expression g to the power of xy mod p will be shared between the sender and the receiver. Okay. Here we have the representation of the Alice between how does the Diffie-Hellman idea will be implemented in the message, sender and the receiver. Okay. So here we have the methodology. What is the security in Diffie-Hellman idea is security of Diffie-Hellman. There will be a discrete logarithmic attack or man in the middle attack. So there may be an attacker who involves between these 2 secret keys. He can obtain both the keys and can decrypt the message. So this is the man in the middle attack. He is the attacker. He gets both the expressions K1 and K2 with a value generated by this attacker, that is Z. So she gets grant to both the keys and gets the message. So this is possible with the symmetric key agreement. Then we have the station to station key agreement, where we use two values. Okay. So this is the method of the station to station key agreement. Alice is considered as a station and Bob is considered as a station. We use the same nouns value to create or generate a shared secret key between the sender and the receiver. So this is about the symmetric key agreement between the sender and the receiver without involving a KDC. Okay, thank you.